This is our video for the notes on 10-3. We're solving exponential equations by rewriting as the same base. We're going to start out with example 3 on this video. We've got 4 to the 4th power, and that is equal to 16 to the power of x. So as we look at this here, right, bases are not the same, right? So these are not same bases, which means we need to change one of them or both of them sometimes. We haven't gotten to those examples yet, but right now I'm going to look at 16. Can 16 be rewritten as base 4? Right? Can you take 4 and raise it to a power to get 16? If you can, then that's great. That's what we want. So we're going to take 16 and we are going to rewrite that as 4 to the 2nd power. So we're going to substitute that in for our 16. So right now we've got 4 to the 4th power is equal to, we're going to say 4 squared instead of 16, and that's still being raised to the power of x. Don't forget about that x. Right, remember the next step here is where we use our exponent rules, right? When we raise a power to a power, we multiply. So we now have 4 to the 4th power is going to equal 4 to the power of 2 times x. And now that we have the same bases, let's just take our exponents and set them equal to each other and solve. It looks like our answer here will be 2 is equal to x. Now to check that one, right, we could say, all right, well, 4 to the 4th power, right, that equals, and if you do that on your calculator, 4 to the 4th power ends up giving us 256. And then we take our 16 and we're going to put it our 2 in for x, so 16 squared is also 256. So we know that this works. We've just checked it. All right, let's go on to example 4. Example 4, we have 25 to the power of 4x equals 5 to the power of 2x plus 12. So in this case, again, we do not have the same bases, so we're going to need to change one. Right, so let's look at the bigger number, the bigger base. Can we rewrite 25 as 5? I think we can, right? 25 is the same thing as 5 squared. So we're going to substitute that in for our 25. So we'll say here 5 squared to the power of 4x is going to equal 5 to the power of 2x plus 12. All right, and I think you remember your steps here, right? We need to simplify this side, use your exponent rules. So we've got 5 to the power of 2 times 4x, which should give us 5 to the power of 8x. And then we'll just bring down the expression on the other side. And now that we've got the same base on each side, let's just set the exponents equal. 8x is going to equal 2x plus 12. Subtract 2x from each side. And we get 6x is equal to 12. And it looks like then our x is going to equal 2. All right, and let's just double check it by putting it in and seeing. Right, if I put 2 in for x in my original, we'd say 25 to the power of 4 times 2, which is 25 to the 8th power. That's going to be a huge number. Okay, so if you want to type that in your calculator, you can. I'll write it out on here, what you get. It's a pretty big number. I think it was, let's see, 152, 587, 890, 625. That's a big one. Let's see here. It looks like 152,587,890,625. Big number. All right, well, the question is though, will this equal the other side? So if we do 5 to the power of 2 times 2 plus 12, that's going to be the same thing as 5 to the 16th power. And you can go ahead and put 5 to the 16th power in your calculator, and if we get the same number, it looks like they will be equal. And some calculators may not even be able to handle all those digits. I'm not sure, but I just put it into mine, and it looks like that actually is going to be our answer. So it does work. Okay, so our value there, x equals 2, works for that. All right, we'll go ahead and include example 5 in this video. We've got 4 to the power of x plus 1 equals 8 to the power of 3x. Now, this is one of the ones where you have to be careful. I'm going to put a little star on this one. Okay, when we look at the bigger number, 8, can we take 8 and rewrite it as 4 to some power? So think about it for a second, right? Can 8 equal 4 to some power? Like right now, if I put 4 to the power of 0, right, 4 to the power of 0 we know equals 1. 4 to the first power equals 4. 4 squared is equal to 16. So you notice 8's not listed in that. So sometimes we have to change both of our numbers. When we look at each of these, we've got 4 and 8. Is there a number that we could use as the base for both of them? So both numbers, or both bases, can be rewritten as what number? So think about that for a second. And if you said 2, you are correct. They both can be rewritten as base 2. 4 is the same thing as 2 squared, and 8 is the same thing as 2 to the third. So we're going to substitute those expressions into our original equation for those values. So here's what it looks like. Instead of 4, we're going to say 2 squared, still raised to the power of x plus 1, equals, instead of 8, now we're going to use 2 to the third power, raised to the power of 3x. Now when we apply our exponent rules, we just need to do it on both sides. So 2 and the x plus 1, and then 3 and the 3x. So our base is still 2, and we're going to have 2 times the quantity of x plus 1. That should equal 2, and then we've got 3 times 3x. So 2 and 2, right, are the same base. So let's just set our exponents equal. 2 times x plus 1 should equal 3 times 3x. And if you want, you can go ahead and just write that as 9x, right? Because that's 3 times 3 is 9. And to solve it, let's go ahead and distribute our 2 through. We've got 2x plus 2 is equal to 9x. Subtract our 2x from each side. So right now we have 2 is equal to 7x. And then we're going to divide each side by 7. So we've got 2/7 is equal to x. And that is our answer. So if you want to take it and plug it in and check it, you would have 4 to the power of 2/7 plus 1. And you can just type that into your calculator like that. Just make sure that the exponent is all in the exponent. And we would also type in 8 to the power of 3 times 2/7. If you type either of those into your calculator, I believe that it's going to give you a value, something like 5.9439, and then it just kind of goes on and on and on, but you can see here if it's giving you the same thing, so we know it is, so it would be correct. So that is your 5th example on 10-3, solving exponential equations by rewriting with common bases. There are practice problems on the other side for you to try, and there will be videos to help you through those in case you need them. If you have additional questions, please make sure you reach out. Otherwise, thanks for watching.